Good morning and welcome to the Maricopa County Environmental Services Department Plan Review and Construction Program presentation on plumbing, the ebb and flow of plumbing and backflow. Today we're going to go over common fixtures and equipment connected to water and sewer throughout a food service establishment. These are our vision and mission statements for Maricopa County Environmental Services Department. Our vision: as the recognized regional environmental leader, we will develop and foster innovative environmental health protection programs for the safety of our residents and their environment. The mission of the Environmental Services Department is to provide safe food, water, waste disposal, and vector-borne disease reduction controls to the people of Maricopa County so that they may live and enjoy living in a healthy and safe community. This is a brief look at our wonderful team and what we do here at Maricopa County. We serve Maricopa County, which is the fourth most populous county in the U.S. Our team is comprised of 11 inspectors and 2 supervisors. Our staff are experienced inspectors who are considered subject matter experts in their field. We are responsible for permitting new construction, remodeling, new owners, and issuing additional permits such as catering permits. We also conduct HACCP and variance review. We provide technical knowledge, professional expertise, and related training to the department and our customers, as well as guidelines related to plan review, plumbing, backflow prevention, and variances. In the fiscal year 2019, staff reviewed 3,759 permit applications and conducted a combination of 8,832 reviews and on-site inspections. Plumbing requirements and cross-connection control. The codes that we are referencing throughout this presentation are current year FDA food code, as well as CFR 21 section 117 and 2009 IPC, which state all water must be from an approved source and always needs to be delivered to an approved sewage system. Thus, it's important to check any plumbing equipment for installation and operational problems. So let's start with hand wash sinks. Hand wash sinks are a very important part of a food service establishment. In the food code, it states that hand sinks need to be conveniently located in food preparation, food dispensing, and warewashing areas, and in or immediately adjacent to toilet rooms. Water to hand sinks must be at least 100 degrees Fahrenheit through a mixing valve or combination faucet. Our code on hand sinks specific to Maricopa County is hand sinks must be centrally located, visible, directly accessible, and within 25 feet of all workstations. Hot or tempered water needs to be provided to all sinks within 45 seconds. And on the right here, we have a hand sink that does not have hot water and cold water being provided through a mixing valve or a mixing faucet, whereas we do on the left-hand side. Faucets. Let's talk a little bit about faucets. These are 3 general faucet types we see. On the left, we have lever faucets, your classic faucet with hot and cold handles. And then we have our metered faucets, which may or may not have both hot and cold handles or just one push handle. FDA food code specifies that metered faucets must remain on for at least 15 seconds per activation. Then we have motion sensor faucets, which, since they are touch-free, do not have a time requirement per activation. Faucets may come with what is called a tempering valve. Tempering water, hot and cold water combined prior to the faucet, is supplied through a properly regulated mixing valve or limiting device that conforms to ASSE 1070 and limits tempered water to a maximum of 110 degrees. Usually you will see this in establishments that have hot water that is set at 140 degrees Fahrenheit or higher to prevent scalding at hand sinks. Moving on to 3-compartment sinks, per FDA food code, wash temperature should be maintained at a minimum of 110 degrees Fahrenheit, and the water supply must be provided with an approved air gap. That is the physical separation between the water supply, such as the mouth of the faucet, and the flood rim of the sink. A 3-compartment sink must be provided to manually wash, rinse, and sanitize equipment and utensils. Each compartment must be large enough to accommodate immersion of the largest piece of equipment utensil used at the establishment, and drain boards must be large enough to accommodate all soiled and clean items. Sinks and drain boards must be self-draining. Prep sinks. There is no requirement in the FDA Food Code for the installation of a separate food preparation sink. A warewashing sink may be used for washing, rinsing, and thawing purposes under FDA, provided that proper sanitizing of the sink is done before and after use. However, Maricopa County's code is if there's any rinsing, thawing, or rehydrating of food items, the establishment must provide a dedicated approved NSF prep sink. Now we'll compare hand sinks to prep sinks. Hand sinks must be properly stocked with a hand drying provision and a hand wash cleanser, and must also have hand washing signage directing employees to wash their hands. Hand sinks must be used for hand washing only, and prep sinks may not be used for hand washing. Hand sinks may be directly connected to the sewer, whereas prep sinks must be indirectly pumped. You can see on the left that the hand sink is going direct to the sewer through the wall. A little difficult to see on the right, but the prep sink is draining to a floor sink with a 1-inch minimum air gap. Also notice that there are splash guards so that there is no contamination from hand washing onto the surface next to the hand sink. Mop sinks, also known as service sinks. The establishment must provide at least one service sink or curbed facility equipped with a floor drain. It must be conveniently located. Toilets and urinals may not be used as a service sink for the disposal of mop water or similar liquid waste. Maricopa County's policy is that mop sinks are required to have a combination faucet supplied with hot and cold water and equipped with an approved backflow prevention device, which we will get into more shortly. An additional water line at the mop sink utility area is required for chemical dispensers, as you can't connect the chemical dispenser directly to the mop sink faucet, which again we will get into later in the presentation when we talk in depth about backflow. In this picture, you can see a dedicated water supply line for the chemical dispenser. Here we have some examples on the left of individual spigots which are not approved for mop sinks. On the right, we have two different kinds of mop sinks, each with a combination faucet. Due to the cross-connection hazards, we need to have an approved backflow device installed on the mop sink faucet in case the operator decides to install a hose, which can create a cross-connection. A cross-connection is a point in a plumbing system where it is possible for a non-potable substance to come into contact with the potable drinking water supply or other food source. On the left, we have our typical mop sink faucet with an integrated atmospheric vacuum breaker. On the right, we have a hose bib vacuum breaker, which has been added to the faucet. Here are some examples of unapproved connections or installations at mop sink faucets. Only the top left example is approved, showing a dedicated water supply line to the chemical dispenser. The top center and top right show a chemical dispenser or other device connected to the mop sink faucet through a Y valve, which is not approved. The bottom left shows a device called a sidekick, and on the bottom right, there's a Y valve with a spray nozzle, both of which are not approved. The main reason for these items not being approved is all these scenarios have some kind of shutoff valve, such as on the Y valve or on the spray nozzle, which are not approved to be installed downstream of the atmospheric vacuum breaker per plumbing code and manufacturer specifications. Atmospheric vacuum breakers are rated for what is known as back siphonage, but not back pressure. When you have a shutoff valve installed downstream, it creates back pressure if the water system is turned on, but the shutoff remains in an off position. Chemical dispensers. Commonly seen in food service establishments at the 3-compartment sink, pre-rinse sinks, prep sinks, and mop sinks. In Maricopa County, we strongly enforce a true 1-inch air gap for backflow protection so that any chemicals pushed through the dispenser cannot get back into the water supply. In this internal view of the two chemical dispensers, you can see on the left side there is a true air gap. Whereas on the right side, it has what is known as a flex gap, which we do not consider a true air gap since the gap is not a minimum 1 inch of unobstructed space. Drain lines. With drain lines, we have two types of connections, a direct connection or an indirect connection. On the left, we see a direct connection, which means there's no disruption or space between the sewer and the drain line. So if there is a sewage backup, it will be able to go into the sink. An indirect connection means that there is a physical break between the sewer and the drain line, so that if the sewage backs up, it will spill out onto the floor before being able to back up into the sink or other piece of equipment. A true air gap is at least 1 inch above the flood level of an approved floor sink or drain. You can see on the right the difference between an air gap and what is known as an air break. Looking at the general purpose sink, there is space between the floor sink and the drain, but because the drain is resting inside the floor sink, it is not a true air gap. So if sewage does back up, it could contaminate that general purpose sink. Some talking points on indirect connections. Indirect lines should not exceed 10 linear feet to an approved floor sink or drain. Food service equipment sinks or service mop sinks cannot receive the discharge of an indirect waste drain. Drain lines under most circumstances should be of a rigid material such as PVC, ABS, copper, or chrome. Flexible tubing can become kinked, is hard to maintain slope to drain, is more easily pushed out of the floor sink, and often is installed as an air break and not an air gap. Drain lines should be properly plumbed and sloped, minimum 1/4 inch per foot to drain by gravity and be secured through the use of durable approved clamps or unistruts. These are typical equipment items that require an indirect connection to a floor sink. You have a condensate drip pan, drain line for walk-in units, ice machines, ice bin, jockey boxes at bars, running water dipper well, food preparation sinks, soda fountains, 3-compartment sinks, ware wash machines, steam tables, steam ovens, tilt kettles, tilt skillets, buffet bars, beer tower, keg cooler drip trays. Looking at floor sinks versus floor drains. On the left, we have a floor sink, which is essentially a mini sink that is built into the floor, sometimes above floor level depending on the circumstances. They can accommodate a large amount of water flow, such as from your 3-compartment sinks or prep sinks. Floor sinks need to be accessible for cleaning and maintaining clean. Floor drains, on the other hand, are primarily for cleaning purposes as they cannot accommodate a large flow of water at once. However, they can be allowed for minor drainage, such as walk-in condensate lines. And here's some examples of improper discharge of waste. On the left side, we have a black pipe which comes from the left and runs along the building and is draining into the parking lot, which can create a stormwater issue. In the center, here what we have going on is the condensate from the walk-in cooler fan draining into a bucket. On the right side, we have some unknown discharge, which appears to be drain lines running from the building out to the grassy area located to the top of the picture. Again, code states that these kinds of waste need to be drained to an approved sewer system. Failure to do so can cause stormwater, cleaning, pest, and hygiene issues. Now this picture here shows some examples of proper discharge of liquid waste. On the left, we have a buffet line with some steam tables. You can see 3 shut-off valves, which allow for drainage of each individual pan on the left, with the drain running to the right to the floor sink with an air gap. The right picture shows a walk station, again with a drain line to a floor sink with a minimum 1 inch air gap. Floor sink and floor drain accessibility. Floor sinks must be accessible to be cleaned and for the inspection of an air gap. When they are placed under cabinetry, for example, they need to be a reasonably sized access panel, as seen on the right, so that someone can get underneath and clean. Ideally, we will have a scenario on the left where not only is it accessible, but it's also readily visible to see if there's anything growing in the drain or clogging the drain, as well as to verify air gaps. And this is what happens if floor sinks are not cleaned or monitored, especially when you have drainage from beverage equipment with products that can feed yeast, molds, and bacteria that can grow and clog the drain. Floor sinks can also become clogged or slow to drain if food or other debris gets kicked into them. This can be prevented with strainers and regular cleaning. Hub drains and risers. When a floor sink is not feasible due to the age of a building or other circumstances, an indirect connection can be achieved through what is called a hub drain, which is on the left. A hub drain is a large funnel where the waste from the sink can drain to, keeping a 1-inch minimum air gap. The funnel allows for a greater flow of water so that the larger equipment can drain without spilling onto the floor. On the right, we have what is called a riser. The piece of equipment, or this piece extending upward on the right, terminates below the bottom of the basin of the sink, so that if sewage backs up, it will spill out of the riser before going into the sink compartments. This slide shows more examples of risers and hub drains. On the top right is an example of a floor sink that has been built above the level of the floor. This could happen to save costs by transitioning a floor drain into a floor sink without heavily cutting into the floor, or due to the grade of the drain. Also, some local jurisdictions require that floor sinks that go through a grease trap be above floor level, so that degreaser cannot be pushed into the floor sink when mopping, which could be the case here. We see in all these pictures that a minimum 1-inch air gap was obtained between the water supply or food equipment to be protected. Condensate pumps and sump pumps. Maricopa County allows these only on a case-by-case basis. On the left, we have a condensate pump running off of a walk-in, and on the right, we have a larger sump pump, which based on the picture looks like it is pumping drainage from beverage equipment, such as coffee and tea brewers. These are installed in situations where there is no floor sink or floor drain in the vicinity for liquid waste to be drained to by gravity. The waste is pumped to a floor sink or floor drain. Water heaters. Per FDA code, the water source and system must be of sufficient capacity to meet the peak water demands of the food establishment. Aside from that, food code is not very specific. In Maricopa County, the minimum capacity requirement for a food service establishment is 30 gallons. Food service establishments with a 3-compartment sink require a 50-gallon capacity water heater unless there is also a dish machine. Then a 75-gallon water heater is required. Larger capacities may be required depending on the needs of the establishment. Here's an example of a label on a water heater, which we can see that the capacity is 100 gallons, but it has a recovery rate of nearly 228 gallons per hour. When calculating hot water demand in Maricopa County, the recovery rate of the hot water heater is more important than the actual capacity, and a minimum temperature rise of 60 degrees Fahrenheit must be used. When we talk about temperature rise, we mean the difference between the expected incoming cold water, groundwater temperature, and the temperature which we are trying to achieve. Water heaters should be set at a minimum of 120 degrees Fahrenheit to ensure water reaches 110 degrees Fahrenheit at the 3-compartment sink, accounting for temperature loss in the piping between the heater and the sink. Our average groundwater temperature is 60 degrees Fahrenheit, so we required a 60 degree Fahrenheit rise to get to 120 degrees Fahrenheit. On the right is an example of our calculator used to determine the needs of an establishment in gallons per hour based on the fixtures using hot water in the establishment. Tankless heaters are becoming more popular and are thought of as an infinite hot water, but that is not truly the case, as each make and model has its own capabilities in regards to how much hot water they can produce in gallons per minute. Maricopa County's policy is an establishment's total gallons per minute anticipated demand must be calculated in order to determine the overall gallons per minute necessary to meet the overall hot water requirements of the establishment, factoring a 60 degree Fahrenheit rise. In general, we calculate the fixture flow rate to be 2 gallons per minute to each faucet, appliance, fixture, or shower head that utilizes hot water or tempered water, with the exception of hand sink faucets, which we calculate at a half a gallon per minute due to the fact that they are usually equipped with aerators. Other equipment, such as dish machines, can be calculated based on cut sheet specifications. On the left here, we have the temperature curves for a series of different models from a particular manufacturer. Compared to the change in temperature, you can see the water flow in gallons per minute. Looking at 60 degrees, each four of these units provides a rate, which is as low as about 4 gallons per minute for the weakest model, but high as 6.5 gallons per minute for the strongest. The right has our calculator for tankless water heaters in gallons per minute, which will determine the number of units of a make and model required based on the fixture demand and water heater gallons per minute capabilities. Recirculation pumps. Recirculation pumps can be used to maintain a constant loop of hot water so that hot water reaches fixtures in a timelier manner. Maricopa County's policy is the installation of a recirculation pump may be required in order to ensure that water reaches sinks or fixtures at a temperature of at least 100 degrees or as required within 45 seconds, or if the length of piping runs are over 60 feet from a water heater. Now let's turn our attention to cross-connection and backflow. Quick definitions. A cross-connection is an actual or potential connection between potable water supply and any non-potable source. Backflow is the undesirable reversal of the flow of water or mixtures of water and other liquids, gases, or other substances into the distribution pipes of the potable supply of water from any source or sources. When we're looking at backflow, we have two types of scenarios, either back pressure or back siphonage. Back pressure is any elevation of pressure in the downstream piping system by pump, elevation of piping, steam pressure, air pressure, etc., above the supply pressure at the point of consideration, which would cause or tend to cause a reversal of the normal direction of flow. You can see this on the left. Back siphonage, a form of backflow due to a reduction in system pressure, which causes a subatomic pressure to exist in the water system, which you can see on the right. Backflow is also defined in terms of containment or isolation. Containment is surface protection, protecting the water main from the building. Isolation is internal protection at each individual point in the system. You may have multiple backflow devices within an establishment to prevent hazards at individual equipment. The degree of hazard will determine which type of device to install. For example, on the left, we have a situation where we have a cross connection between the potable water supply and sewage, so we are looking at a high hazard situation. On the right, we have a coffee and tea brewers, which are considered low hazard. Assessing the degree of hazard, as well as potentials for back pressure and or back siphonage, will lead you to appropriate backflow devices for the application. A backflow preventer that provides high hazard protection will be acceptable for low hazard applications, pending back pressure, back siphonage requirements. Here's a chart that makes it simpler to determine which kind of backflow device or assembly would be appropriate for a given situation. We will explore these in the rest of the presentation. Air gap is the highest level of protection one can achieve for backflow. It is a true physical separation. Per plumbing code, an air gap is to be a minimum of 1 inch or twice the diameter of a pipe. This is more important when it comes to the actual potable water supply. In Maricopa County, for drain lines, we will often accept 1 inch as there is usually an air gap at the faucet or system supply itself. Here is an atmospheric vacuum breaker, which meets ASSE standard 1001. And as a side note, ASSE stands for the American Society of Sanitary Engineering. Atmospheric vacuum breakers are designed to protect potable water supplies from back siphonage and are rated for high hazard. No downstream shutoff valves are allowed and are to be used only with non-continuous pressure. It should not be under continuous pressure for more than 12 hours total. It must be installed at least 6 inches above any downstream piping or hose. This is what are installed on mop sink faucets typically. In RY, we cannot have chemical dispensers installed on mop sink faucets. This is a reduced pressure principal zone assembly meeting standard ASSE 1013, also known as an RPZ. RPZs are rated for high hazard in both back pressure and back siphonage. Here you can see the inner workings of an RPZ. There are 2 check valves with a relief valve in the middle. This is what gives an RPZ one of the highest levels of protection in terms of backflow assemblies. In case one of the check valves fails, the fluid that has undergone backflow will empty from the relief valve. On the right, we can see 2 RPZs that have been installed. Note that one is stainless steel for use on a soda carbonator or RO system. When the hazard we are trying to address is acidity such as carbonator for soda system or reverse osmosis system, no copper or copper alloys, such as brass, may be installed downstream of the backflow preventer. On the left, we can see that there is a piece of copper that has been installed on the downstream side of the backflow, which is not approved. On the right, we can see there's only stainless steel or flexible tubing that has been installed downstream of the backflow. Just above the ice machine, you can see a double check valve assembly, which meets ASSE standard 1015. These are very similar to an RPZ, with the exception that it does not have a relief valve in between the 2 check valves. Due to this difference, RPZs are rated for high hazard due to that extra protection, but double check valve assemblies are only rated for low hazard. Both assemblies are rated for both back pressure and back siphonage. Here we have a series of spill-proof pressure vacuum breakers which meet ASSE standard 1056. Here are the internal workings of a spill-proof pressure vacuum breaker. There's only 1 check valve, unlike an RPZ. They have height installation requirements, 6 to 12 inches above any downstream plumbing, depending on manufacturer specifications, which prevents their use from certain applications. They're rated for high hazard and back siphonage and continuous pressure that does not exceed supply pressure. Here's an example of a pressure vacuum breaker which meets ASSE standard 1020. The pressure vacuum breaker is very similar to the spill-proof vacuum breaker, with the exception that, as the name suggests, the spill-proof vacuum breaker will not spit water if there is a backflow event. This makes spill-proof vacuum breakers ideal for areas that are not protected from moisture. PVBs are commonly installed on irrigation systems. Here we have double check valves with atmospheric vents, which meet ASSE standard 1022. Here's the internal workings of a dual check with an atmospheric vent. While it has 2 checks in a vent like an RPZ, it is not testable. These are intended for beverage equipment such as coffee and tea. Food code states that these are acceptable for soda systems. In Maricopa County, we strongly recommend the use of an RPZ instead for soda systems. In the field, you may see 1022 lookalikes such as 1024 and the 1032. They may look similar to the 1022, but they do not have an atmospheric vent for added protection. Aside from the vent, you can usually locate the ASSE number on any device to determine what it is. Here we have hose bib vacuum breakers meeting ASSE 1011. Here one is installed on a faucet for a sink used as a service sink. These can be attached to the end of a faucet or a hose bib. While rated for high hazard, they are not rated for constant pressure, only back siphonage. And here's the example of the inner workings of a hose bib vacuum breaker. Water is allowed to flow out, but if there's any back siphonage, it will close, preventing backflow and dumping water before getting into the faucet. Now we're going to cover some common cross-connection and backflow scenarios that you might see in a food service establishment. In this example, we have a can wash. The drain in the center has a water supply to spray water up into inverted trash cans. An RPZ is required here, which you can see installed towards the top left. Here we have an example of open-ended hoses that are very common in food service establishments. They can create a cross connection with food service equipment, sinks, floor sinks, buckets, etc. A hose bed vacuum breaker or an atmospheric vacuum breaker are common solutions for backflow prevention. Garbage disposals. The most common backflow device you will see in an atmospheric vacuum breaker. In this picture, it is located to the left of the pre-rinse faucet. The vacuum breaker must be installed 6 inches higher than any downstream plumbing and cannot have any shutoff valves installed downstream. Shutoffs installed downstream are a common error that we will see in the field, but can usually be corrected. Chemical dispensers. Most dispensers can be equipped with an internal air gap. If it cannot or does not meet local code requirements, an approved spill-proof vacuum breaker or RPZ may be installed. Hoses with spray nozzles. You might see hoses like we have on the left at a pre-rinse station or dish pits. A spill-proof pressure vacuum breaker is the most common backflow protection. An RPZ is also approved. As we have discussed, atmospheric vacuum breakers are not rated for shutoffs downstream. So in a restaurant, you might see a spray nozzle connected to the mop sink faucet. This is not approved. Since AVBs are not rated for constant pressure, the sprayer may be used for cleaning but must be taken off when not in use. Here we have a pot filler with hose, often seen installed with an atmospheric vacuum breaker. On the left, the hose does not have a shutoff, so this is acceptable. On the right, however, there is a shutoff handle on the hose, making it not approved. An SVB or PVB would be installed instead. Here we have a keg washer commonly seen in breweries. Due to the pressurization of the machine and the hazard with the chemicals involved cleaning the kegs, an RPZ is required for this installation. Glycol cooling systems. If a glycol cooling system is connected to a water supply as opposed to an air-cooled system, an RPZ is required. Pre-rinse sinks or sprayers, an air gap is required. The easiest solution is to make sure that the spring to hold the hose out of the sink is installed properly, or the neck to the sprayer is tall enough. Reverse osmosis water filtration systems. Due to the fact that removing minerals from the water makes the water have a pH below 7 and is slightly acidic, an RPZ is required. Water-cooled ice machines. Ice machines are typically installed with a double check valve assembly, as you can see on the left here. Soda machine carbonators. Again, due to acidity, an RPZ is best, but code does allow for a dual check with an atmospheric vent, an ASSE 1022, with a Y strainer. In Maricopa County, we require these to be replaced yearly if installed in lieu of an RPZ. Coffee and tea brewers. A dual check valve with an atmospheric vent is approved. Espresso machines also have a dual check valve with an atmospheric vent requirement. The same goes for juice machines connected to a water supply. Water-connected coffee machines cleaned with chemical tablets will require an RPZ instead of the 1022 due to the chemical hazard involved. Water-cooled frozen dessert machines and other water-cooled equipment that do not involve chemicals will require a double check valve assembly. drip trays, such as from a beer tower or a soda machine, an air gap is required at both the beverage supply and at the drain line. Glass rinsers, commonly seen in bars and at beer taps. They are treated like a submerged inlet, and an RPZ is required. Other types of rinsers. Left to right, we have a different version of a glass rinser, a wand-style blender rinser in the middle, and an in-sink blender rinser at the right. All require an RPZ due to the submerged inlet. Self-cleaning hoods. These are becoming more popular, incorporating water with chemicals to rinse the inside of the hood, keeping it cleaner for a longer period of time. An RPZ is required for the water line. Pasta cooker. Ideally, these will have an air gap. You can see to the top right above the basket where the water line has an air gap above the flood rim of the cooker. Some pasta cookers will have submerged inlets. In that case, an RPZ is required for installation. Tilt skillets and tilt kettles. Ideally, we will have an air gap because only a faucet will be installed. Occasionally, there will be a hose that can be left on the edge of the skillet for filling, which due to the cross connection would require an RPZ. Combination ovens or combi ovens require an RPZ due to the chemical hazards with self-cleaning. These ovens will either have chemicals directly connected to the unit or will have chemical tabs to be placed inside for the cleaning cycle. Combi ovens may come with a spray hose as well, which can create a cross connection. Rotisserie ovens connected to a water supply for steam and cleaning will require an RPZ. A chiller for pizza dough will require a spill-proof pressure vacuum breaker. Walk stations. Most of the time an air gap is all that is necessary because water comes from the faucet at the back. Occasionally a submerged inlet may be installed in either the front or the back of the walk station. In that scenario, an RPZ is required. Rack oven. A double check valve is required. These are considered low hazard compared to combi ovens because there is no chemical self-cleaning. Rethermalizer. Due to the submerged inlet, an RPZ is required. Likewise, an autofill steam table, due to the submerged inlet, will require an RPZ. Buffet lines. If water is supplied at the buffet table itself, typically you will see a faucet for filling, which will provide an air gap. Dipper wells will require an air gap. Live seafood storage tanks will also require an air gap. Produce misting systems. Due to the potential hazard of Legionnaire's disease, an RPZ is required for installation. This goes the same with patio misting systems. And here we have a few slides of code references from the FDA food code so that if you're out in the field and see issues, you can write a violation as appropriate. We have 5-203.14, backflow prevention device when required. We have 5-203.15, backflow prevention device carbonator. You have 5-204.12, backflow prevention device location. 5-205.13, scheduling inspection and service for a water system device. 5-402.11, backflow prevention. 5-205.12, prohibiting a cross connection. 4-101.14, copper use limitation. 5-202.13, backflow prevention air gap. 5-202.14, backflow prevention device design standard. Here's a list of Maricopa County's resources you can use for future reference. Always double check against the codes you are authorized to enforce by your employer. All right, do we have any questions?